Today we will talk about gastrointestinal agents. Now let us see what are acidifying agents. These are the substances that increase the acidity in the stomach. There is a condition called ochlorhydria where there is no secretion of HCl in the gastric secretion. The symptoms are abdominal pain, loss of appetite, diarrhea. So we are using dilute HCl for this. Now it contains 10% weight by weight of HCl. This is a clear, colorless, tasteless, odorless liquid. This is mobile with water and organic solvents. Acidic to litmus, reacts with iron to change the color. This is stored in the well closed in a glass container below 30 degree, and this is incompatible with alkali metals, bases, metal oxides, iron and oxidizing agents. Now, as such, there is no this is not used medicinally as such, but only as acidifying agent in ochlorhydria and hypochlorhydria. Let us talk about what are antacids. The substance which neutralize excess HCl secreted in the body is called as antacid. They act by altering gastric and urinary pH. They do alter the rate of dissolution, absorption, bioavailability, and renal elimination of number of drugs. They act by neutralization mechanism whereby carbon dioxide gas is liberated. Now, what are the properties we consider for an ideal antacid to be effective? It should be first of all insoluble in water, and it should have fine particle size. Secondly, it should not produce systemic alkalosis. Also, it should produce its effect gradually over a long period of time, and it should have no side effects. It should be stable, readily available, and it should not involve large quantities of gas on reacting with HCl. Aluminum compounds as antacids. Aluminum hydroxide gel. This contains not less than 3.5%, not more than 4% of L2O3. Then we talk about dried aluminum hydroxide gel. This contains not less than 47% L2O3 and not less than 47%, not more than 60% L2O3. This is a light white amorphous powder containing some aggregates. This is odorless and tasteless, insoluble in water and alcohol. But this is soluble in mineral dilute acids and alkali hydroxides. Then we have aluminum hydroxide tablets, which are prepared by wet granulation method. The fourth in this category again is dried aluminum phosphate gel. This contains not less than 80% aluminum phosphate. If you see the properties, it is a white powder containing some aggregates. It is insoluble in water and ethanol, soluble in dilute acids, and practically insoluble in solutions of alkali hydroxide. Then we have aluminum glycinate, which is NH2CH2COOL OH twice XH2. This contains not less than 34.5 and not more than 38.5% of Al2O3, and not less than 9.9, not more than 10.8% of hydrogen. This is white powder, odorless, practically insoluble in water and usual organic solvent, dissolved in dilute mineral acids and aqueous solution of alkali hydroxides. Now, uses of aluminum salt: they are mild astringent, absorptive properties, used in the treatment of peptic ulcers, and hyperchlorhydria. So hyperchlorhydria is opposite of chlorhydria. Here there is a more secretion of HCl, and peptic ulcers because of Helicobacter pylori, that is the infection. Then we talk about calcium compounds as antacids. We have calcium carbonate. This contains not less than 90%, not more than 100.5% of calcium carbonate. Occurs as a chalk, limestone, marble, calcite, aragonite. Preparation: Sodium carbonate plus calcium chloride gives calcium carbonate and NaCl. This is available as fine white crystalline powder, odorless, tasteless, and insoluble in water and alcohol. If we see the reaction, it reacts with carbonic acid that gives CaHCO3 twice and reacts with ammonia to give calcium, ammonia, H2O and water, carbon dioxide. Talk about magnesium compounds as antacids. They have heavy magnesium carbonate and light magnesium carbonate. The heavy magnesium carbonate is available as granular powder and light magnesium carbonate is available as very light powder. Both are white, odorless and tasteless. They are insoluble in water and alcohol, insoluble in mineral acid with effervescence. Then we have heavy magnesium oxide and light magnesium oxide. Both are white powder, odorless, slightly alkaline in taste and practically insoluble in water, alcohol and dilute mineral acid. They readily absorb carbon dioxide. We have milk of magnesia, which contains not less than 7% and not more than 8.5% made by weight magnesium hydroxide. It is prepared by following reactions. MgO plus H2O gives Mg twice, or MgSO4 and NaOH will give MgOH twice. Magnesium hydroxide contains not less than 95%, not more than 100.5% magnesium hydroxide. Properties: it is white, fine, amorphous powder, practically insoluble in water. Yield solution which is slight alkaline. This dissolves in dilute mineral acids. We have magnesium trisilicate, contains not less than 29 and not more than 32% MgO, and it does not contain more than 65 and more than less than 65, not more than 68.5% of silica. Now this property, it is a fine white powder free from glutinous, odorless and tasteless, insoluble in water, and when it is treated with acid it decomposes. When treated with HCl, MgCl and tricilic acid also. This is used as cathartic. Light magnesium carbonate is used as adsorbent and preventing the formation of eutectic mixtures in capsules, also as non-systemic antacid and laxative.